Okay, so the video that we're going to look at is from the movie Mean Girls, and it's showing a math question where the limit doesn't exist. And after this video, I'm going to try it, show you guys how it's done, and that's pretty much it. So let's get into it.
Find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you. The limit is -1.
That answer is incorrect. And we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Don't exist. The limit does not exist.
Our new state champions, the North Shore Mathletes.
Okay, so we just saw the scene from Mean Girls, and it's a limit question. Just a simple limit question, but how do you do it? I mean, she said does not exist. And it seems like such a complicated question. How do you know that it just doesn't exist? She did it so quickly too. Genius level, right? It's actually crazy. Now, the thing is, it's actually a very complicated limit, and you could do approximations and you'd get the same answer. You can use some calculus. I'm going to do the calculus way. And you can also graph it. You can go on Desmos graphing calculator and plug in that exact equation that you saw on the video, and you should get where you're approaching 0, x equals 0, and the y value keeps going up to infinity, but also goes down to negative infinity. So since they don't match as you approach 0, it can't exist. It just does not exist. So I'm going to show you how to do it using calculus, using L'Hopital's rule. L'Hopital's rule. So here, the rule is L'Hopital's rule. And what you do is, you do the limit. Let's say you do the limit and you get 0 over 0. An indeterminate form, you're going to need to use derivatives on both the numerator and denominator, and then do it again. So I'm going to show you how it works. So let's say we got limit, which is the question during the video, as x approaches 0 of natural log of 1 minus x minus sine x all over 1 minus cosine squared x. You substitute 0 for x. Usually that's what you would do. And what you're going to end up with is natural log of 1 minus 0, which will be natural log of 1 minus sine of 0 all over 1 minus cosine squared of 0. And what you get is natural log of 1 is 0, sine of 0 is 0, 1 minus cosine squared of 0 ends up being 1, which equals 0 over 0. This is an indeterminate form, and you don't know what the limit is. Now, you could think that it just doesn't exist because of this, but sometimes it doesn't really mean that. Sometimes it actually ends up being where you have an answer. So let's forget this method, and now we go to L'Hopital's. So L'Hopital says we need to take the derivative of every single term and then substitute 0 in again. Now, what does that really mean? What is a derivative? I mean, it's essentially slope. It's the slope of this equation, slope of this equation, and slope of this equation all together. I'm just going to tell you what the derivatives are, and you could probably look it up exactly how to do it, what to do. This video is not meant to teach you that, but it is to show you simple concept of L'Hopital's and a simple way to find the limit if you end up getting this. Derivatives are a little complicated. I'm here to teach you L'Hopital's rule, not derivatives. And here it goes. So let's say we got the limit again. Limit as x approaches 0. Natural log of 1 minus x. The derivative of this ends up being negative 1 over 1 minus x minus sine x. Derivative of sine x is cosine x. Cosine of x all over derivative of 1 is 0. Now an easy way to think of this is if you drew a graph of 1, y equals 1, you're going to end up with a straight horizontal line, and that does not have any slope, so it's 0. So the slope of this is 0, so we don't really need to worry about that. Alright? And then we take the derivative of cosine squared x, negative cosine squared x. And the way to do that is simple. You do negative outside, bring the 2 down, 2 cosine of x, and then derivative of cosine x is sine x, negative sine x. Sorry, negative sine x. And then let's say you substitute in 0 again. What are you going to get? Well, let's see what we get. We substitute in 0 again. And this is exactly what L'Hopital says. You take the derivative of every term, then you do the limit again. Take the limit again, and you get negative 1 over 1, because 1 minus 0 is 1, minus cosine of 0. And as I set up here, cosine of 0, cosine squared of 0, is 1. So same thing, cosine of 0 is 1. All over negative. Now let's see. Cosine of 0 is 1, but sine of 0 is 0. So essentially what we just did was we did 0 times the entire term, which ends up just being 0. It doesn't really matter about the negative, so we could just leave that. It doesn't exist really. Positive, negative, doesn't matter, it's 0. And then we get equals negative 2, because negative 1 minus 1 is negative 2, all over 0. Now this is interesting, because we just got an undefined answer. Do we say it's infinity? Do we say it's negative infinity? We don't really know for sure. But the thing is, here's what I see, is that during L'Hopital's rule, if you end up getting something that looks like this, we just say it does not exist. Does not exist whatsoever. That's what we say. That's what L'Hopital says. Or at least, that's what we believe. Okay, so DNA does not exist. Simple way, simple notation. Now another way you could do it is graph it. You could graph it. And the thing is, what you will end up seeing is if I graphed it. If I ended up graphing it, we will end up with something that looks like this. Well, I haven't drawn it yet, but see this XY axis, and you just draw it, and there's multiple graphs that you get to see. It's kind of a cool equation to look at, but the gist of it, just looking at 0, you'll end up seeing something that looks like this, and this. When you are near 0, when you are near x equals 0. And the thing that happens is that this keeps going, this line keeps going, approaching negative infinity, and this line keeps going, approaching positive infinity. And since those two limits, the positive infinity and negative infinity, approaching x equals 0, they don't coincide with each other. So that just tells you the limit does not exist. It does not exist whatsoever. Now, that's only because as you approach 0, it actually has two values. If it looked something like, if it looked like this, let's say I drew another graph, and if it looked like that, it's approaching 0 no matter what. X, as you approach x equals 0, the graph approaches 0 from both the left side and the right side. In this case, from the right side approaches negative infinity and approaches positive infinity. So that's why it doesn't exist. The limit doesn't exist altogether, and that's the answer. Mean Girls was right. Or, I'm sorry, the girl in the Mean Girls film was correct in saying that. He was very quick in determining that. That was actually very impressive, I'll tell you that. But yeah, that's pretty much it. It's all you need to do. And it pretty much works every single time if you get an indeterminate form. That's it. Comment down below another movie or a TV show or practically anything with a math or science concept, and I'll look at it and potentially make a video out of it.